Hey everyone, welcome to the Cannabis Technologist. With me today is Alexei Peshkovsky, if I pronounced that correctly.
Very well, yes, remarkably.
I can't believe I never get it right. Alexei's president of Industrial Sonomechanics, LLC. Alexei's got a great background. He's got a BA at chemistry at Penn. He's got his PhD in chemistry at Columbia. And Alexei's goal or his objective as a company is to be a major player in the field of ultrasonic liquid processing. So, Alexei, why don't we kind of start at a high level and then work into it? Can you give me kind of a baseline for new viewers? What is ultrasonic liquid processing?
Sure. High-intensity ultrasound put into liquids creates a process called acoustic cavitation. Acoustic cavitation is a phenomenon that leads to the formation of a very large number of extremely strong microjets. These are very fast, very tiny jets that are responsible for shear forces that can break up particles if there are particles suspended in the liquids or break up cellular walls. So if you have particles that you'd like to make into nanoparticles, for example, oil suspension, oil droplets suspended in the water, those will become nanoemulsions, nano droplets of oil suspended. If these are crystals, they will become nanocrystals suspended. It can break up cellular walls and release the contents of the cells, and this is useful for extraction. Other processes that occur independent, these are separate things, but also very useful, is degassing. So we work with that. And there's a range of sonochemical reactions that are promoted, mass transfer limited, when you need to deliver reagents to each other, and those reagents don't like to mix normally, like oil and water, similar things. So this is what our equipment is designed for, and that's what we'll work with.
Okay. Well, the name of your company is Industrial Sonomechanics, and it's a research and development, it's equipment design and process consulting firm specializing in high-intensity ultrasonic liquid processing. So having said that, what is technically, what technique is it most commonly used for?
These processes that I listed. Mostly we work with situations where a nano material needs to be created, like a nanoemulsion, breaking up the droplets of oil suspended in water. That converts a common emulsion into a nanoemulsion. We're making nanocrystals, or degassing, or cell disruption, things like that.
Okay. At what point did you realize that there was going to be a tremendous need for your technology in the cannabis industry?
So our equipment is primarily designed for the pharmaceutical industry. This is our typical client. That has been our typical client for the past about 10, 11 years or so. What they frequently, or I would say maybe mostly, need to do is deliver some sort of an active pharmaceutical ingredient into the bloodstream, into the human body. Most active ingredients happen to be non-water soluble. They may be oil soluble, but they don't dissolve in water. So in order to deliver them efficiently, you need to make them appear to be water soluble, to be as close to being water soluble as possible. So nanoemulsions and nanocrystals give you a way of doing this, and we can get into this in a little bit more detail later. But our equipment is designed for those guys, for this kind of process, for the pharma. And then the pharmaceutical, the cannabis industry exploded about a year and a half ago with basically the same need. There's this cannabis extract. It's a type of oil. It's not compatible. It's not soluble in water. It's difficult to deliver into the bloodstream. That's why people have all these different methods of consuming it: vaping, dabbing, smoking, edibles. There's no one simple method that just wins, like with alcohol, for example. You just drink it. You wouldn't vape it, right? Because it dissolves in water, so
Right.
it's easy to deliver by just drinking. So
Sure.
we saw this clear need, and it's the same need that the pharma companies have always had. And we realized that our equipment is already prepared, and our expertise is already there for this. We didn't even have to redesign the equipment. We adjusted the formulations a little bit that we work with. But basically, we were ready. And I would say now the cannabis industry is probably 80% of what we do.
Okay. That's significant. Can you briefly tell us about the barbell horn ultrasonic technology, acronym BHUT, how it allows you to scale up from lab to bench to industrial production without lowering the intensity of ultrasound?
Sure. Our company was built around the invention of so-called barbell horn. It's a device that lets you increase the sizes of the processors without lowering the amplitude. The amplitude essentially is the intensity of ultrasound. One translates into the other. The intensity has to be high for anything meaningful to occur. It's basically like volume of the sound. If the sound is very quiet, your ear has trouble picking it up, right? So for you to be able to do some meaningful work, it has to be loud, or in this case, it has to be intense. So there are many different approaches to making high-intensity ultrasound on lab scale. However, scaling it up has always been a problem in the ultrasound field. There was no way to make things bigger and retain the intensities. The intensities would always drop, and they would drop significantly by a factor of 5 to 10. So the reputation of this technique wasn't very good. You could achieve all these wonderful things in the lab, but as soon as you scale them up, you would lose all the results. We essentially calculated ourselves out of this predicament. This was done by my father, who was an ultrasound physicist his entire life. So he came up with this mathematical concept of a barbell horn that goes around this seemingly fundamental problem. And we patented this, created the device, formed a company around it. It worked very well, so we could scale up. And then we, throughout the years, added a few more patents to it. So this technology has a nice portfolio of protection around the world. And this is basically the core of what we have. We can experiment on small scale and then directly scale up for production. Anything that can be done in the lab can now be done in industry.
That's exciting. Are cannabinoids more effective in water-compatible nanoform? Are they more, I would guess, convenient to administer?
Definitely, yes, on both counts. So from the pharma applications, we know that things like the onset of action and the bioavailability of drugs that are not water compatible, or the oil-based drugs, is enhanced tremendously when you put them in what seems to be a solution. This is normally something called translucent nanoemulsion. Very technically speaking, it's not a solution, but it looks as if it were, and it mixes with water. So you could make out of cannabis a material, a water-compatible material that behaves more or less like alcohol. And with alcohol, you know that if you have a drink, you'll feel it in 10 minutes, maybe 15 minutes, maybe even faster on an empty stomach, right? And then it'll be fully in after an hour. With cannabis, if you consume it as an edible, it'll take, an hour for you to feel something. If it's THC, then maybe after a couple hours, it's at its peak. This is not a way to dose a patient. Also, the bioavailability, which is how much of it makes it to the bloodstream, what percentage of what you consumed makes it to the bloodstream. is very low for direct consumption of non-water compatible substances because they have to make it all the way to your small intestine. There they have to be broken apart and taken in, and that depends on your metabolism, that depends on your gallbladder function, on what else you ate, what time of day, on who you are. For medical cannabis, it's impossible to prescribe a dose. It depends on too many things. You could trick it and use your lungs by smoking it. Well, first of all, you're not meant to bring things into your body through your lungs, except oxygen. Second of all, people exhale very differently from each other, so it's impossible to prescribe an accurate dose because 80% is exhaled. If you could just consume it as you do alcohol, it would be perfect. The entire dose is in, and it's in quickly. Well, this is what nanoemulsions, nano-formulated cannabinoids give you. And we know that the bioavailability goes up indirectly because studies have been done on many very similar active pharmaceutical ingredients by the pharma industry. Unfortunately, since it's difficult to get funding to do a clinical trial for cannabis at this point because it's federally illegal, there is no exact number for cannabinoids for this. But these numbers really belong to a method, not so much to the drug itself. This method of formulating roughly gives you 5 to 10 improvement. That seems to be the average. And the onset of action, 5 to 10 improvement in bioavailability, and how much of it is going to make it to your bloodstream. And the onset of action seems to be about 15 minutes or so. So not quite the same as alcohol, but much, much closer. So yes, they're much more effective and they're much more convenient. On the convenience side, another thing is you could just add these water-compatible formulations to any drink. You can put it in water, and it will go completely clear. It disappears into it. You don't see it. It's not hazy. You can add it to your tea, to your juice, to any drink that you're consuming, and have a strong dose in it.
Yeah, it's really impressive. And at the end of this webcast, I want to direct people to the website so they can see there's a video posted where you visually see what you're talking about, and it's something to see. So that's great. I'm curious, Alexei, what products and services does Industrial Sonomechanics offer to those who want to produce their own water-soluble cannabis extracts?
We offer 3 ultrasonic processors, laboratory scale, bench scale, and industrial scale, as well as what we call stabilizer packages, which are essentially surfactants. They're food grade, generally regarded as safe, completely safe pharmaceutical level surfactants that, in conjunction with our equipment, can be used to produce translucent nanoemulsions. Lab scale equipment is good for investigation, optimizing your formulation. If you don't want to use our stabilizers, which of course you don't have to, you can just use your own. Now, if you use ours, there's no need for any research and development. There's a simple set of steps that you can follow and produce with either the bench scale system, it's a production volume system, or an industrial scale system, which is much bigger than that.
Gotcha. What productivity rates can be achieved with your bench scale processor? For example, how many water-compatible 10 milligram cannabis doses can be produced per hour?
So with the bench scale system, you can make between 5 and 10 liters per hour. A liter can contain, depending on the concentration of cannabis that you're putting in there. For example, if you're putting 20 milligrams per milliliter in the nanoemulsion, then 1 liter will contain 2,000 doses, which means if you're making 10 liters an hour with this system, you can produce 20,000 doses of a pretty strong cannabis emulsion. That is if you consider 10 milligrams to be a dose, because half a milliliter becomes the 10 milligram dose. It doesn't mean that you have to stop at 20 milligrams per milliliter. You could make things more concentrated. There is a bit of a drawback because if, let's say, you make a nanoemulsion with 50 milligrams per milliliter, then your dose becomes 0.2 milliliters. And that may be difficult to dispense. If you make a little bit of a mistake, then you're dispensing too much or too little. So I would say most people choose to produce 20 milligrams per milliliter nanoemulsions, which for 10 liters gives you 20,000 doses per hour.
Wow. That really illustrates the effectiveness. Interesting. So, Alexei, over the next 6 months to the year, what kinds of new and exciting things can we look to see from Sonomechanics? What's kind of on the horizon for you guys?
We are working on water-based extraction. We would like to develop a method and are actually working with some preliminary good results, a method for extracting cannabinoids into water, not into any kind of solvent, but into water. And we believe that we're able to do this because in order to extract something from a plant, generally you would need to use a solvent. People use CO2 for cannabis, alcohol, there's an ethanol, hydrocarbons, things that dissolve cannabinoids. Water is not really used except for hash, that's just mechanically breaking off the trichomes. But for extraction, water is not used because it doesn't dissolve cannabinoids. But as I demonstrated, as I described earlier, we make cannabis appear to be water soluble. And that may be good enough. We essentially trick cannabis cannabinoids into behaving as if they were water soluble. And we believe that because of that, we can use water as this sort of pseudo solvent for it. Right. And it seems to be working. If that works out, we'll have a method of solventless extraction that would be completely safe, completely green, relatively easy to do. So this is what we are hoping to achieve. I would say maybe in the next 6 months. That's about the right timing. Wow.
You're moving fast.
Trying to.
Incredibly, yeah, I can tell you're busy. This has been a really compelling interview. Thank you so much, Alexei. We want to be able to direct people to your website to learn a bit more about what the company's doing, and how would you direct our listeners?
Our website is just www.sonomechanics.com. SONO, like sound, Sona, and the word mechanics. Sonomechanics.com. And most of our cannabis information, cannabis-related articles, of which we have many, is actually not on the website, but in our blog section. So if you go to our website and click blog on the top right, you will be directed to a completely different website that has a lot of blog posts where you can find medical cannabis section. And that has tons of articles on extraction, on making nanoemulsions, with formulations, with description of the equipment, general information, just background, educational materials. So, yeah.
And I second that. I was there last night. There's a host of material in there that's quite interesting, and you can get lost in it very quickly. So, good stuff. Alexei, thank you so much for the webcast. We'd like to do it again. We'll be watching you guys closely.
Great.
And thanks so much, and let's chat soon.
Thank you. Thanks very much for having me.
Okay. Thanks, Alexei. That's it, everyone.
Okay.
Take care.